My name is James Pope. I'm a lecturer of data science at the University of Bristol. And I did this work along with Ayush Joshi. Ayush, if you're in the room, there he is up here, and also Mohammed Hassan, Mohammed, right back over here, as well as Hugh from the Gene Golding Institute. So we were actually looking at tone bias in open source skin cancer data sets. The next slide, I think yes, it is the next slide. There are some images that they're not, well, I don't think they're too bad, but if you don't like medical images, they are images of moles, and some of them are pretty hard to look at. So if you don't like those, you might want to leave or at least look away, but at least most of the slides will have a couple of those. The next one particularly does. The other thing I want to say before I present is that we're basically data scientists. We do machine learning. We're not clinicians, okay? So everything I'll talk about today will simply be about the data. Any medical interpretation, anything else like that, I'm not qualified, so we'll steer away from those. Okay, so these are certainly what is happening with computer vision. One of the very nice things with, if you will, advances is the fact that they do pretty good. If you actually take the picture of a mole, they're pretty good at actually determining whether that's potentially cancerous or not cancerous. So this has been quite a success story. So normally these will get state-of-the-art. It's going to be above 90% accuracy. There are a number of studies out there. They're quite large studies in Nature, etc. And so this has been going on for some time. However, when I was looking at this, and we basically started looking at this and teaching this in 2020, the story that we started, we kind of trained it on it. We gave a nice, we're actually at Bristol Data Week last year, and actually a number of colleagues and students brought up the thing of, well, I wonder if there's any tone bias in these, in the results here or in the models and what they're learning. And so that's actually how we ended up here today. So what we did with the Seedcorn funding is we wanted to go out and just to see, is there tone bias? In these open source data sets. We went out, one of the larger ones is this ISIC data archive. It's actually about 40 different data sets and quite often used. Again, open source, you can go out and basically has a picture of a mole with the skin background around it and whether it's cancerous or not, sometimes different types of moles. And the problem we immediately ran into was most of those, there are probably 100,000 of those images, most of them did not actually have the skin tone. So we don't know, which was quite unfortunate. Only about 2 or 3% of the images actually provided that. Actually, about half of those, about 1,500 actually came from Argentina. So in any case, we had to concentrate on that subset. The future work that we're going to do is going to look at basically trying to figure out the skin tone of the other 97,000. So we actually, part of this study was to actually come up with the tone classifier. The data set itself, it doesn't quite, the visual is quite lost, but the point is that in the data set of the 3,000 images that we had, most of them, 85% were actually of light skin. Very few actually were dark skin, and this certainly corresponds with other studies that we have seen. And actually, at least with the light skin, there's more chance of cancer, more prevalence of cancer than in the dark skin, or dark tone, I should say, data set. So whether that actually reflects in the population or not, I don't know, but certainly within the data set, these were the statistics. And actually what we did is we then trained machine learning models, fairly typical standard machine learning models that would take the image in, and again, you've got the mole and you've got the background skin tone, and it would output learn how to output benign or cancerous. And so one of the things we did not answer in it, but one of the things you might be wondering is what did it learn? Is it actually learning the shape of it, the color of it, the contrast, etc.? How is it learning to differentiate? Again, it does quite well on this task, but why is it doing well? We didn't answer that in this study, but what we really want to see is, was there tone bias? Is there a difference between it? And we'll answer that in just a moment, but these are some questions that we would like to answer later in the future. And so you don't have to wait too much longer. Here's the answer. What we did is on the bottom, it's a little hard to see, but or to explain it, is that at least for the dark tone, it doesn't do that well. It gets about 0.26 correctly predicting cancer, and for the light tone, it does quite a bit better. And one way that you actually can measure, there are other ways, but one way you can measure bias within machine learning models is actually just looking at that ratio. And then you say, okay, well, what's a bad ratio or what's a good ratio? Well, normally anything below 0.8 is considered, there may be potential for bias. And so we ended up finding that within this data set, this 3K images, 0.5 suggesting that it could be bias within this data set in these models and what they're learning. So this is some additional things that we're looking at. Again, as I mentioned, this is only with the 3,000 images. We would like to look at all 100,000 images. But to do that, we actually have to determine the skin tone for those because they don't have it. Which certainly motivates that when you do these studies that you should capture that, ideally, right? But in any case, we can at least try to do that. And these are just some of the results where we're trying to basically identify where the mole is, and then so we can just concentrate on the background skin color to detect the tone. So that's future work, as well as other future work, as I mentioned, the skin tone classifier. The other thing that we looked at was, if you don't know, those numbers were quite how can one say, summarized. That was after, I don't know, 3 weeks of letting my computer run, and it was getting very, well, so multiple computers running. And so in any case, we need more computational resources, and obviously we want to learn, understand what did the model learn, so obviously explainable AI will need to come next. And that is it. So thank you, and I think we'll take questions at the end, if I understand.